So we're going to start with just some mental math, going back to Unit 7. How do we evaluate these expressions, and really what does this mean? So look at the very first one. When I evaluate this is log base 3 of 27. That's how we read this. Mathematically, I'm thinking to myself, if I want to write this in exponential form, if that helps you to evaluate this, it's 3 raised to some unknown value equals 27. So 3 raised to what number equals 27? So that's not 3 times something, it's 3 times itself. How many times? 3 times 3 is 9, 9 times 3 is 27. So this evaluates to 3. Another way we're going to learn about this expression today is that we can think of this in more than one ways. Another way to think about this is writing log base 3. Now I know that 27 is the same as 3 to the third power. So I can rewrite 27 as 3 to the third. In this form, we're going to learn about today how I can take whatever this exponent is and I throw it in front. 3 to the third power means 3 to what power equals 3? Well, that'd be 1, and 1 times 3 is 3. So there's more than one way to think about how we can evaluate these expressions. 6 to what power equals 36? The answer is 2. 7 to what power equals 1? The answer is 0. Now, I'm going to trick you coming up here. I want you to think about this, and I'm not going to ask anybody for an answer. I want you to raise your hand if you know what log base 3 of 1/9 is. Hands up high. Okay, if you don't, that's okay. So what I want to do is I want to ask myself, if I just thought about this as log base 3 of 9, I would say to myself, 3 to the what power is 9? And the answer would be 2. But notice that the 9 is not on top, it's on the bottom, which makes this a negative 2. Next up, 16 to what power equals 4? Well, so what can I do to 16 to evaluate the 16 under these certain conditions to equal 4? And the answer is, if I could take the square root of 16, it would equal 4. But how do I represent the square root as an exponent? Remember that there's a hidden value here. It's called the nth root, and that's a 2. And so when we rewrite it in exponential positions, it's written as a 1/2. 16 to the 1/2 equals 4. This means what times its value? 2 times equals 16. The number is 4. All right, down here, I want you to raise your hand when you know what this one is. Log base 2 of -4. Log base 2 of -4. Okay, as a quick reminder, this value can never be a negative, can never be negative. This value can never be negative. And in fact, this value can never actually be 0. So we'd say this is undefined. Okay, this one is very similar to this one, and I wrote it down twice because it confuses students so often. So I'm thinking of this as log base 2 of 4. And I'm saying to myself, 2 raised to the what power is 4? 2 to the second power is 4. Okay, that's easy enough. So 2 to the second power is 4. But we can see the 4 is not on top, it's on the bottom, making the exponent negative. 8 to the what power is 2? Now that is tricky. I'm going to press pause. Okay, about 4 of us. All right, so I've just asked students that are live in the classroom to see how many of them understand this. I'm going to write this in exponential position. So 8 raised to I don't know what number equals 2. How do I turn 8 into 2? I can't take the square root, but I can ask myself, what times itself a certain number of times equals 2? What times itself a certain number of times equals 8? And I know that 2 times 2 times 2. 2 times itself 3 times equals 8. That makes this value, it's called a cube root. A cube root. Instead of a square root, a cube root, since this is 3. 2 times itself 3 times equals 8. 2 times itself 3 times equals 8. Okay, let's look at the next one. Again, I want you to look at these next two, and I'm going to press pause. Similar to this one right here, this is how we're going to relate these. What if I just said log base 8 of 2? Well, that would give us what? That would give us 1/3. We know that this would evaluate to give us 1/3. But notice that the 2 is not in the upper positions, it's in the lower position. So since we've switched it to the lower, this is not a 1/3, it's a negative 1/3. It's a negative 1/3. Okay? And right over here, we are unable for this value directly behind the base to ever be a negative or 0. We say that is undefined. Okay, that's just a quick review from the last unit. We're going to get started right now. If you're going to write anything down, these are the most important things to write down. If you are rewatching this, please take time to press pause and write down these 3 key properties that we are going to use throughout today and throughout this unit. They are property of logarithms. We consider this to be condensed form. Condensed is pushed together. Now we can rewrite it in an equivalent form called expanded form. Notice that in condensed form we have multiplication in the value behind the base. But in expanded form, multiplication turns into addition. Similarly, in condensed form we have division. In expanded form we have subtraction, with the numerator going first and the denominator going second. And like I showed you on the very first example, there's multiple ways to evaluate log expressions. When we have an exponent, we are able to rewrite this exponent by placing it directly in front of the log and multiplying it by the value of the log. So those are 3 properties we need you to have down, and we're going to see those throughout. I'll actually be coming back and putting this up front so you'll have multiple opportunities to write these down. Let's look at the very first one right now. So I would like you to look at this one. Now this looks like our very first example. So if we are going to evaluate this, we got to think, are there more than one way we can do this? And if there is, then you're going to choose, if it doesn't tell you which way you have to use, you're going to choose the way that makes most sense to you. So I'm going to demonstrate 2 different ways. And if I can find a different colored pen, that would help me. So the very first way that I'm going to do this is that I know that 8 times 4 is 32. So log base 2 of 32. And in my mind, I'm thinking 2 to the what power equals 32. So 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 2. So if I take 2 times itself 5 times, 2 times itself 5 times, I end up with 32. I just evaluate this expression, done. Good to go. Can I have a thumbs up or thumbs down if you understood that example? Okay. Now, if they said to you, hey, first you need to expand this. This is in condensed form where we're using multiplication. Now, expanded form looks like this. I'm going to take whatever's first. I'm going to turn multiplication into addition. So now I've expanded it, and I'm going to say 2 to what power equals 8? 2 to the 3rd power equals 8, and 2 to what power equals 4? 2 to the 2nd power. 2 to the 2nd power equals 4, and when I add them together, I still end up with 5. I want you to understand both methods. Unless they are specific with you, you get to choose whatever method makes most sense to you. So similarly, let's look at this one. So when we look at this next example, my mind right away is like 2 to what power equals 32? It's 5. I'm done. That seems simple. If that works for you, great. Now, if that's a really large number, we do want to know another way we can do this. So here's an alternative method that we could use. I could break up 32, and I want to break up 32. I have to use the same base, which is base 2. I want to break up 32 into values that I can take 2 to. So for instance, I could break up 32 to 2 times 16. Now, why can I use 2 and 16? Because 2 to what power equals 2? 1. Remember, when I break these apart, I'm rewriting this as log base 2 of 2 times 16. And when I turn multiplication, like we did up above, it turns into addition when I expand it. So it's log base 2 of 2 plus log base 2 of 16. Log base 2 of 2 is 1. Log base 2 of 16 is 4. And now when I add them together, I still end up with 5. You are not going to have to show both ways, but I want you to recognize both ways. Can you help me out right now? If you recognize both ways, thumbs up. If you're like, no, I'm only really recognizing one way, thumbs down. Okay, let's look at the next one. Now, I want us now to place this back into condensed form. So we're working with the same type of thing for the first 3 expressions. Here, I want to condense this because I think it'll be easier for me. So I want to condense this, and I'm going to write log base 2. Now, addition, when I condense it, goes back to multiplication. And again, 8 times 2 is 32, so log base 2 of 32, and we get an answer of 5 by evaluating it. Now, others may have said, like, I don't want to condense that. Let's just go ahead. I know 2 to the 3rd power is 8, 2 to the 2nd power is 4. And again, you can see that I'm doing the exact same thing in multiple times, and we can still achieve the same answer of 5. Now I want us to press pause, and I want you to look at this 4th example, this expression. When I press pause, I want you to come up with 2 different ways that you can evaluate this expression. Go. I'm going to demonstrate right now 2 different ways. Here's one way that I could do this. I'm able to easily simplify that 81 divided by 9 is 9. And I know that 3 to what power is 9? 3 to the second power. There we go, I've evaluated it. This is the equivalent to 2. Now, is there a second way we could do this? Sure there is. I could take this and expand this. So log base 3 of 81, remember division when we expand it turns into subtraction with the numerator going first, and log base 3 of 9. So 3 to what power is 81? 4. 3 to the what power is 9? 2. And when I subtract, I still end up with 2. They are equivalent. Our last example is like the third property. I'm going to take whatever the exponent is and I'm going to throw it in front. So it's 3 times log base 2 of 4. That exponent goes in front. And now I'm going to focus on this portion, knowing that after I evaluate this, I'm going to take it times 3. 2 to what value is 4? The answer is 2, and 3 times 2 is 6. Let's expand each one of these expressions. So right now, think of this as log base 10 of x times y. When I expand this, log base 10 of x, multiplication turns into addition, plus log base 10 of y. My next example, as a reminder, natural log, ln, can also be rewritten as log base e, whatever you prefer. So ln of m, again division, when we expand it, turns into subtraction. Subtract ln of n. The one thing to remember here is that your numerator will go first, followed by the denominator. This third example is just like the third property. We're going to take the 3 and we're going to throw it in front. So 3 times log base 2 of a. The fourth example is similar to this example, but there's an extra part to it. So instead of only having 2, one on top and one on the bottom, we now have 3 items. ln, and I'm first only going to apply it to the top. So ln of x, multiplication turns into addition, plus ln of y. So I've taken care of the numerator. Then I'm going to take care of the denominator. Division turns into subtraction. I only have one thing behind it, so I can use parentheses, but it's not really necessary when there's only one item behind. And we have the ln of z. So if I was going to rewrite this, addition turns into multiplication, and subtraction turns into division. We are halfway done with these examples of expanding logarithmic expressions. Okay, let's keep going here. Log base 4 of x, multiplication turns into addition, and log base 4 of y squared. But I'm not done yet. Property number 3 says if we have an exponent other than 1, we need to take it and we need to throw it in front. So that 2 is going to go directly in front of log base 4 of y. Okay, I'm going to stop. It's not going to be completely done with this example. We have 4 left, so hold tight. I'm going to stop, so I'm not going to completely simplify it, and I want to see if you recognize how I could take it one step further. All right, here we go. ln of the square root of x, subtract ln of y. Please raise your hand when you recognize how I can go one step further. One person, 2, 3. Okay, well, let's rewrite this. ln of x, remember square root is equivalent to taking something to the 1/2 power. And property number 3 today says that if we have an exponent that's anything other than positive 1, we need to take it and throw it directly in front of that logarithmic expression. So it's 1/2 times the ln of x, subtract the ln of y. We're going to jump back to what you learned. For many of you, that's with Miss Castro. And before I get started here, I'm hoping that you look at this trinomial and you recognize that it's factorable. Because I'm thinking to myself, what 2 numbers multiply to give you positive 6 and combine to give us positive 5? What 2 numbers multiply to give us positive 6 and combine to give us positive 5? So log base 10, that would factor into positive 3 and positive 2. X plus 3 and x plus 2. This is like property number 1. So I have two quantities, I'm multiplying them. When I expand it, multiplication turns into addition. So log base 10 of x plus 3 plus log base 10 of x plus 2. And it is important that we also put them in parentheses so it doesn't look like it's just log base 10 of x and then there's this plus 3 way behind it. I'm going to press pause. We have 2 left. I'd like you to try to expand this expression. This square root is applying to the x and to the y, so I'm going to start by just rewriting that. ln of x square root of x over the square root of y. And I may even rewrite it again. ln of x to the 1/2 over y to the 1/2. Now when I expand this, division turns into subtraction. So ln of x to the 1/2 subtract ln of y to the 1/2. And all of this looks great, but we're not done yet. Remember, we have an exponent other than 1. It needs to be thrown in front. So 1/2 goes in front. We have 1/2 ln of x subtract 1/2 ln of y. The last one appears easier, but there's a trick to it. There's a trick to it. Our last expression of part 1 of this video is we are going to expand it, recognizing that we have a numerator and we have a denominator. And so I'm going to start by putting brackets or parentheses here. Log base 2 of a, that's the numerator, and then division turns into subtraction. And in the denominator I have log base 2 of bc. And now I need to continue to expand whenever possible. There's nothing more that can happen here. There's no exponent other than 1 that can go in front, so the numerator is fine. Now if you want to keep the parentheses or brackets there, that's no problem. But in the denominator, I see that I still have multiplication, and that multiplication can still be expanded. So log base 2 of b, multiplying turns into addition, plus log base 2 of c.